Responsibility in ScyNet is defining the blockchain protocol. That is, when you have a couple of computing nodes, one node that tries to provide, for example, AI, another node provides data, how do you actually make a foolproof protocol that can allow this whole system to interoperate and create AI for the masses? We're trying to create a decentralized network of computing nodes. And every computing node is going to execute one type of algorithm that tries to create AI. And what happens is that every once in a while, these nodes are going to submit their best algorithms in the network. We call them agents. And we have defined a specific network consensus algorithm that cryptographically proves the exact performance of these agents without the actual miners revealing their inner working. And hence miners have incentive to keep purchasing computing power because they're betting that in the next competition, the next tournament, they're going to score more than their objective. After these, let's call them regularly scheduled verifications of agents, the network consensus awards the best ones with the token of ScyNet. On the blockchain, it's written that this agent has this performance, and it's pretty much guaranteed that that's the case, or that was the case for the validation round. What happens is that we can have external clients, like other nodes in the network that don't really contribute with computing power. And what these nodes do is these nodes can browse the agents that have been already verified, and they can try to purchase those that have, for example, good performance. But purchasing, I mean that they could, for example, pay the computing node that created this agent to use the agent. So the agent still stays in the computing node. Computing nodes can get money if their agents are good, directly from the clients, and if they win the competitions, and the clients can get crucial access to cutting-edge AI. And what's different and unique about ScyNet in this case is that, okay, there have been a couple of blockchain networks that try to help with the creation of AI by providing access to data, or by allowing you to publish your already created AI on a marketplace and other clients can rent it as usual. But there hasn't been a network that pretty much emphasizes on the creation of AI. Everything that has been created so far requires you to submit an already good AI. But what we're trying to do with ScyNet is achieve a completely autonomous network that allows you to either help create the world's best AI or use it for a fraction of the cost. So our main goal building the ScyNet framework is building an ecosystem that allows you to create blockchains for all sorts of AI problems. For example, one AI problem could be predicting the stock market. Another AI problem could be trying to make autonomous vehicles more efficient. And another could try to make the most precise weather forecasts in the world. So what we are really aiming for is we really want to be able to create better and better AI algorithms in pretty much all areas where AI is currently being applied to. And we're pretty much trying to disrupt whatever we can with this technology. I think I'd say yes, because in the end of the day, AI is just a bunch of very basic building blocks working with very basic logic. And when you think about it, our brain is kind of the same thing. We've got neurons, which form a little bit more complex structures, and they're kind of repeated around the brain. I mean, we still have no idea how it works, but it still works on a compound level. So while it may be extremely difficult, it may take us a lot of time, I think that there's nothing stopping us from creating AI as powerful as a human brain and even more powerful in general. I was always interested in trying to utilize my time to make something functional, make something useful. And when I was introduced to computer science or programming in general back in 8th grade, I was really surprised to see that you could actually type in a couple of words in a text file and it could turn into a functional system that you can actually try to solve an actual problem. So this is what really sparked my interest in computer science in general. It's a very scalable technology which you can actually use to solve problems despite your initial lack of experience. So at early ages, I started competing with different projects. For example, I made a handwriting machine. I made a couple of apps that I published in Google Play, a couple of games that got a couple of thousand users. And one guy that noticed me is Todor Kolev, which is the current chairman of the Comrade Cooperative. So at one point he met up with me and he presented the idea of Comrade. And this really, let's say, inspired me because, as you understood, Comrade is an entity that allows a group of people to get together to split the responsibility of developing a specific project so that only they are responsible to bring this project to life. You actually know the value of your work, you know what's going to happen if you don't do the work, and failure or success depends mostly among you and among your team members. And that's what really inspired me, because we're removing the standard structure, which is really inefficient. We're only bringing people who actually want to work together, who want and take responsibility, and we have the complete freedom to do as we choose in order to deliver this project. This is what really got me into Comrade.